So in machine learning, we are always fighting a battle between simplicity and accuracy. Today we are going to settle the debate between three most popular tree-based algorithms, which is decision tree, random forest, and boosting. We aren't just talking about them, we are going to train them live in the browser to visualize exactly how they think. So let's start with the foundation. First up, the decision tree. Think of this as a game of 20 questions. The model asks simple yes no questions to split the data. If I click on it, you can see, right? On the complexity as a 5, the things happen like it. But here it builds a boxy rectangular structures, right? You can see right here, right? It's a simple and interpretable model, so that's why it sometimes um, doesn't perform that much well, right? So if I increase the complexity uh, to 50, crank it up, right? Um, there is a weakness, right? Now you can see that those boxy rectangular structures got disappeared, but it's overfitting, right? It's trying too hard to be perfect on training data, which means it will fail on real world data. So how do we fix that? We use random forest, right? So this technique is called bagging. Instead of one smart tree, it builds 100 dumb trees. Each tree sees different random subsets of that data, and they all vote and take the majority. If we look at the boundary now, we can see it's much more smoother and organic. The random forest ignores those tiny outliners because only one or two trees might see them, right? When we tried in decision tree at the complexity of 5, we can see that it was also including the outliers. But in this, there's no chance of getting outliers, right? This is the wisdom of the crowd. It lowers the variance and makes the model incredibly stable, right? Finally, we have the heavyweight champion, the boosting, like ADA boost or XGBoost, right? This is sequential learning. Random forest build trees in parallel, boosting builds them one by one. Tree 1 tries to solve the problem, tree 2 looks at the error, right? Tree 1 made and tries to fix only those. Tree 2 tree 1 first solve the problem, then tree 2 looks at the errors, and tree 1 again tries to fix only those errors, right? Not much more than that. If I refresh it and go to add a boost and click on train, there you go. Okay, refresh it. Let's increase the complexity a bit. Yes. So random. So looking at the decision boundary, it is incredibly precise. Boosting focuses laser-like attention on the hard points where the red and blue moons overlap, right? So if I increase the complexity, okay, let's just first increase the complexity. If I crank it up to the max, it comes at a cost. Because it observes over mistake if your data is noisy, like if it has some outliers. Like in this, we have some outliers. So boosting will try to fix the noise. It is much more prone to overfitting than a random forest if you aren't careful. That's why at lower also it was still overfitting a lot. So yeah, we have to take care of that. So at conclusion, which one should you use? Use a decision tree if you need to explain the logic to your boss, right? In a very simple, single-handedly, right? Use a random forest if you want a robust model that works well out of the box. Stability. Use boosting, just like XGBoost, if you are in a competition and need the highest possible accuracy, performance. People usually use XGBoost in Kaggle computations. It just increases the accuracy a whole lot better. So this was just that's all in this video. Thank you.